just a small memento of the occasion, and we'll on the way out.
Or radio. Anyway, I'd like to welcome you all to the New York City area if you're not from the area. And if you took the transmitter tour, you're going to be seeing a lot in here of what you already saw today. And so we'll begin. Now, this past weekend, January 18th, we marked an historic event in the history of broadcasting, as it was the 100th anniversary of Marconi's first two-way transatlantic communication. It was an event that helped lead the way to the field of broadcasting that we know today, and Marconi was truly a pioneer in our field. It seems rather fitting that we're here tonight to take a look at another pioneering venture. As you know, WOR is one of America's pioneering broadcast stations, having signed on in Newark, New Jersey, February 22nd, 1922, on the top floor of Bamberger's department store in Newark, New Jersey, to sell these newfangled radios. And in the annals of radio history, we were one of the first people to actually pull a well-known radio move. After they sold the radios in that Christmas, they said, "For licensing, we don't need it anymore." Luckily, they didn't do that. They talked old Bamberger into keeping it, and WOR went on from those humble beginnings to become one of the major players in the golden era of radio, and has been a part of many firsts, such as having one of the first directional transmitting antennas in the United States, being one of the first stations to utilize a profanity delay, especially when Joan Rivers was on the air. And on October 11, 2002, WOR took another pioneering step when WOR HD was born. Initially, we were approached by Ubiquity Digital Corporation to become an IBOC test station, and Ubiquity was looking for a powerhouse AM station to help in the final testing of AM IBOC. And WOR would be a part of helping FCC rulemaking, nighttime IBOC testing, and receiver manufacturer testing. Buckley Broadcasting and WOR made the decision that if we were going to have an IBOC signal on the air for testing, we would go all out to show our support for what could possibly be the next evolution in broadcasting. Tonight we'll be concentrating primarily on AM IBOC. AM and FM IBOC are very similar. Quite frankly, with the FM, there are many different combinations and decisions to make in how you are going to put it on the air, depending on power level and a lot of other factors. So we could be here all night. We only have the room till 9. But AM IBOC is much easier to implement. It took us 3 hours for what you saw on the site today. Quite frankly, let's see, I just lost my spot. Anyway, if you have any specific questions regarding FM IBOC, I ask that you seek out Brian or Dick from Harris or Jeff or Rush from Ubiquity. They could answer questions, or Ken Brock will be sitting over here trying to hide behind the computer. In reading things regarding the implementation of IBOC, you get the impression, first of all, that you need digital everything, starting with your consoles. WOR implemented IBOC using our original 1978 KRNE System 1 consoles. They're mono. The way the story goes, when WOR or RKO General was asked to divest themselves of their licenses, is when this project started in 1978. They had to cut the budget. They took the right channel out. And these are originals. These are not quite the prototype, but they are like serial numbers 1, 2, 3, 4, and 5. They do have vector card cages in the output stage. And they still run. They still make spec. They still sound good. So, and our lease at 1440 Broadway is coming up in about 3 years. So, not knowing right now what corporate wants to do. We don't know if we're going to stay where we are, if we're going to move to a different floor, if we're moving to a different building. If we're buying a building, jumping off the roof, we have no clue. The corporation didn't want to put heavy dollars into renovating the studios right now.
60 days notice, though.
That's right. You're being generous there. We are in the process right now. We did buy some used consoles to tide us over. They are stereo. We will be stereo by this summer. So we will be able to put stereo programming on WOR. Nice. The WOR transmitter site was rebuilt in 1997. It was wired with stereo in mind. From our studio switchers all the way out to the transmitter, we are stereo. However, the studio end is another issue. We do have an ENCO system in at the studio. It has been wired stereo. The production room is stereo. So just about anything that gets put into the ENCO is in stereo. All we have to do is take the mixing pad off and we put the stereo consoles in. We have stereo audio. So The iBox exciter and equipment, which is in the lower right-hand corner of the racks, fit in with no problem. We had room. It's right down here. The only problem we had was depth. Those are very narrow racks. They were put in the late 1960s. Having deep racks wasn't the norm. But if you keep the back door off, we have a fan blowing in there just to keep airflow through the rack. Everything works out fine. Now, WOR maintains several different STL paths to the transmitter. Now, first, a non-data compressed interplex STL over a Harris Aurora 5.8 gigahertz spread spectrum radio. Next thing we have is a Mosley DSP 6000 system, which is stereo. We have a Mosley 6020 receiver, which is mono. We maintain an 8 kilohertz mono phone line, just in case. We have 2 hours of the best of WOR on a DAT machine in case we have to abandon 1440 Broadway. We also have an an ISDN setup, so if we had to abandon our studios and Broadway, we can go broadcast with somebody else, and we have a studio at the transmitter site. Now, with this variety in a backup transmitter chain to maintain, the WR STL inputs and outputs are analog. We convert the analog audio after a passive switcher to an AES signal with a radio system's A to D converter. And I borrowed some slides from Harris. Gary Leibich from Harris was supposed to be with us tonight. He had an emergency and family couldn't make it, so I borrowed some slides. One of the things you need for audio processing in STLs, you need separate processors for the analog and digital channels. The processors should accept AES inputs and outputs. The iBox equipment does take AES, doesn't take analog inputs. So if what you have is analog, you can always convert it to AES. They should be clocked from the same source, which makes sense. You don't need frame slips. It says the STL should be all digital. Well, we're doing it with digital paths, but we have analog input and output. In one case, actually in 2 cases, we have analog STLs and they work just fine. If you're going to be using a digital STL, it should be linear. Now, the DSP 6000 is a data compressed signal. It actually doesn't sound bad for the iBox on the air. We use the interplex, which is non-compressed, as our primary. Once the signal comes out of the AES converter, it goes into the EASU, or Exciter Auxiliary Service Unit. The unit serves several purposes. It controls aspects of exciter operations, such as keeping WR's transmitter on external or internal excitation. So if the exciter were to fail, there's a relay installed in the transmitter and in an interface box on top of the transmitter that will switch the transmitter almost instantaneously over to analog. So we'll stay on the air. And we did have an issue one day. We were testing for WLW, with WLW for nighttime operation. Kerry Richards, our chief engineer, stopped in the next morning to reset the exciter and shut the toggling off. We had a program running that would turn the HD on and off. And we're not quite sure what the problem was. We think it was because it was a dry day. He had a sweater on and didn't discharge himself to the rack, but when he touched the front of the exciter, it rebooted. And the transmitter went pop, and it flipped right over to analog, and we stayed on the air, and this was a morning drive. We didn't hear boo about it. No one said a word. So it does work. When that exciter went away, so did the digital, and we would just revert it right back to analog. It also acts as an AES distribution amplifier. So what happens is, out of the AES converter, put it in this unit, acts as a DA, which one side of the DA feeds the analog processing, the other side of the DA feeds the digital processing. The output of the AE feeds analog and digital processors. The Optimod 9200 feeds our analog signal. The 6200 feeds the digital side. And on the back of the 9200, it does have this does have the modification for the AES in and out. Some of them don't have that modification. If I'm not mistaken, that is the factory mod that you can get from Orman to plug it in. It's not a real big ticket item. And out of the processors, you go into the exciter. And the exciter, as you have heard at the site, or may not know by now, is a computer running Linux. The Ubiquity program runs under Linux. It's got a touch screen on the front. And at least on this version, this is the Ubiquity exciter, and we'll have a picture of the back. It uses Cat5, shielded Cat5 cable to get between the exciter and the transmitter. The commercial exciters, such as the Harris exciter, the Dexstar, and the ones made by DE, those are made with broadcasters in mind. They have the NC output for the RF, they have XLR connectors for the audio. They look like something you install on an FM transmitter, or an AM transmitter in this case, and they're broadcast friendly. Not that this wasn't, but it was just different. On the back of the exciter, you've got a jumper that goes down to the EASU. The analog and digital inputs, that does say analog input. It is not an analog input. That is the input from the analog processor, which is AES. It won't accept an analog input. The exciter does have a modem in it. We could dial into it if necessary. It's got an Ethernet port. It has TCP/IP capability. The green connectors at the bottom are for remote controls. You can remote control many aspects of the exciter. Right now, we've got control the HD on and off, the audio delay ramp up and ramp down, and we can force it to bypass mode if necessary. But there are other controls that can be mapped, such as bringing your sidebands up and down in column level if necessary. And of course, Cat5 cable over here in this corner. And we borrowed this slide from Harris. It basically shows the processing chain. It says one choice. If we were talking about FM, you've got multiple choices. AM, you've got one way to go. Your tab processor, your analog processor, go into the exciter, gets converted to the iBox signal, feeds the AM transmitter. External carrier in is actually a signal that contains the RF, and it is phase modulated with tertiary carriers. The audio input contains the analog signal from the analog processor, plus the primary and secondary carriers. And the etal on this is the EASU. That's Harris's name for it. This shows the block diagram of the typical AM configuration where it comes into the etal, goes out to the processors, goes back into the exciter, which feeds the magnitude signal, which is the analog, and the RF signal into the transmitter. Has the control and GPS antenna. And Russ, what's the purpose of the GPS on this? Is it block time standard, or?
The reason for the GPS antenna is so that when we have multiple iBox stations on the air, it will allow radios to tune from one to the other more quickly because they'll be synchronized.
And we go from the exciter over to the Harris DX50, which is WOR's main transmitter. And right about there on top, and we'll see a close-up of it in a minute, is the interface box that's involved with this exciter. Many of you saw the Continental today. That does run. It does work. We run it on the air every Saturday night during Joe Franklin's show, which is fitting because he plays 78s, and quite frankly, they sound good through that transmitter. But it gives us some good exercise. And Doherty modulation, we highly doubt that would pass an iBox signal. We haven't tried it and don't want to because we don't want to see it arc over. Probably wouldn't like the iBox very much. But the interface box lives on top of the transmitter. Takes the Cat5 in. This is relay control and the audio going into the transmitter and coming back from the other processor. Around the back side, or right about in this point here, is where a BNC connector comes out that goes to the input of the transmitter. And there's the close-up. You've got the Cat5 and the input and output cables. Now you may notice the shield wires running down here. You may wonder why we did that. The Sunday we installed this, we opened up the box that said shielded Cat5 connectors, and we opened it up, and there were not shielded Cat5 connectors in there, and Radio Shack doesn't carry them, so we had to punt. It was called a spade lug. We had to ground the cables, and they've actually been working and haven't been causing any grief. So, in the transmitter, this is the oscillator board in the DX50. The BNC connector is the external input. The way the DX50 does it, there's a jumper over here. It's a manual jumper that will switch between internal and external excitation. The little blue relay over here is controlled by the box on top. And if the exciter fails, that relay will drop out and will revert the transmitter back to its internal oscillator. Transmitter will dump for about half a second when that happens and come right back up on its analog input. And most listeners, I doubt, would even notice. It's just quick boom and you're back. Harris for the DX50 is going to be coming out with a replacement board that has the built-in switching on it. So it'll be a connection to the exciter. One issue we had when we installed it in the DX50 was we brought it up to 50 kilowatts. We had it on the dummy load, and the dummy load is a little funky these days. And it promptly decided to fold its power back to 25 kilowatts and brought itself back up to 50. And we kind of said, must be the dummy. So we put it on the air. It promptly took its power level but down to 25 kilowatts and brought it back to 50. And behaved for about a minute, maybe two, and did the same thing. There is a little glitch in the way the DX50 is sensing the bandpass VSWR, and the way the DX50 does it. It's got a VisWire detector on between the PA and the output stage. It's got a VisWire detector between the output stage and the antenna. So the bandpass filter, or the output of the PA, is where we were seeing the VisWire hits. Harris right now said, jumper that point to ground, which effectively disabled the bandpass VisWire. Talking to Gary Liebisch the other day, they had a transmitter operating at 1600 on the factory floor, which was glitching. They found a way to solve it. They were tuning it to 710 this week, and to see if the same fix would work at 710. Apparently, the 1600 fix did not require any component changes. It was just some adjustments. So, by next week, I should have instructions on what to do, and we can get rid of our little friendly little lead over here. We broadbanded our antenna system in 1997. Now, I don't know if you took a look at the WOR towers when you were out there, but we have the antenna system from hell. You may have noticed all the other transmitter sites you drove past on the street. The first thing you would notice on our towers is that each tower has two skirts. And those skirts are to electrically shorten the towers at 1190 and 1010 to get the reactances of the towers to a manageable level at the base of the tower. In the tuning house, we've got detuning networks for 1010, 1190, and 620. We then have traps for 1010, 1190, and 620. And then we actually have the tuning network. So when we went through the system, we also found that two of the tuning houses were phase lead networks. One was a phase lag, so we standardized everything to a phase lead. We put in line stretchers. We redid the phaser, which we had to because of the line stretchers, but we also put a line stretcher in here. And by the time we were done, we came out with an impedance plus or minus 15 kilohertz from carrier that was fairly flat. It's within about an ohm. And it's not quite ruler straight, but it's pretty solid. After 15 kilohertz either side, it goes absolutely bonkers. I've never seen a common point before that looks like a sine wave. This one does. But that plus or minus 15 kilohertz is plenty to pass IBOC. If there we go. Now the challenges with AM, you need to obviously accurately reconstruct the digital signal, dependent on good linearity of the magnitude and phase channels. Part of that's the transmitter. Part of that's your antenna system. If you don't have good linearity, you get IMD products in the audio, which will degrade the digital signal. You could also have high IPM. AM stereo, reducing the IQ ever the IPM. The best way to achieve the linearity is to have a wide modulator bandwidth. The ordinary transmitter just won't pass it. It doesn't have a very wide modulator bandwidth. Many PDM transmitters are somewhat bandwidth limited. So if you have a PDM transmitter, you're going to want to check with the manufacturer to see what you'll have to do to broaden that out, if it can be done at all. In many cases it can be. Talk to the manufacturer. If you're going to reduce your IMD products, you want a wide modulator bandwidth. That bandwidth needs to be 50 kilohertz at least. You want a fairly wide bandwidth for the RF chain. Starting to sound like a solid state transmitter for the iBot signal. Your IPM or IQM needs to be at least minus 35 dB or less. For a PDM transmitter, you're going to want your switching frequency to be greater than 150 kilohertz for a multi-phase PDM system. You'll need to correct or optimize the bandwidth limiting filters. And if you have a well-designed filter, of course, the transmitter will be optimized for DAB performance. Once again, take a look at your transmitter, call the manufacturer, find out what you'll need to do. The DX series was pretty much plug and play for us. We plugged it in, turned it on, if it gave. It accepted the signal without an issue. Transformer plate modulated. iBot probably won't do it. Time for a new transmitter. Single phase PDM transmitters, 75 kilohertz. I'm thinking MW5. Probably going to have problems with iBot. You probably need to have the filters redesigned if it'll pass it. All depends on the IQM. The polyphase transmitters need some modifications, and I've been told by Harris we have several in the Buckley chain that they will be coming out with modifications and instructions on how to do that. This is the baseband of the AM iBot system, the way it's constructed. Your host analog audio sits here in the center, plus or minus 5 kilohertz, and the audio is bandwidth limited to 5 kilohertz. Kerry and I, when we first put this on, part of Kerry's background is that he worked for United Artists Theaters for a good number of years. Has been trained in THX at the Skywalker Ranch. Set up quite a few theaters here in the New York City area. So the first thing I said was, we're going to reduce bandwidth to 5 kilohertz. And what are you, nuts? So we went out to the transmitter, and he sat in his car, and I flipped it down to 5 and walked outside, and he said, so when are you going to do it? I said, done. He had a typical car radio in his car. Couldn't hear it. Could not hear anything past, give or take 4 kilohertz. He couldn't tell the difference. And we went back and forth. Riding under the analog post signal are the tertiary iBot carriers, which are phase modulated. At minus 40 dBc on the outside are your secondary upper and lower sideband carriers, which extend from approximately 5 to 10 kilohertz. And on the outside from 10 to 15 are your primary carriers, which run at minus 28 dBc. And of course, you take a look at that and say, well, gee, how does that relate, and is it legal with the NRSC mask? There's WOR with the NRSC mask drawn in. They're allowed minus 25. There we are at minus 28. We're just a little bit tilted on the upper sideband. That comes up to minus 30. Here's your minus 40, minus 38. And it fits very nicely under. Now, some things you can do with the iBot. The next load of software we're expecting from Ubiquity, and by the way, the first load of software we had sounded good. It sounded a little real audio-ish, if you will. This load, and many of you heard it today, is a vast improvement. Sounds pretty good. Russ told me they are presently testing load number 3 for AM. Make sure it has no issues, and we'll be seeing that hopefully in a couple of weeks. He says, listening to it today, it's about 1,000 times better than what we heard today. So AM iBot is still somewhat of a work in progress, and every time we've gotten the software load, it's been a major improvement, big improvement. However, the other thing with the new software load is we're going to have this 40 bits per frame of data available that is constantly available with all modes of operation. So we can tell you that Joan Hamburg is on the air right now on your radio. We can tell you that the commercial is Flemington Furs. We can possibly put the headline from the newscast up on the radio. So you'll have that available as if you had an XM radio or you dial up on the internet, you know what's playing there because they tell you. You can tell people. You also have data capacity that you can rent out for various services. One of the most interesting services I saw was at the Harris Roadshow. They had a radio with a video screen attached to it. Now, this is something you put in a cab. This is something you could put in a bar. And on the radio, they had a baseball game. And on the screen, there was a baseball diamond and the stats of the game. And when Russ Munchink came up to the plate, his face showed up on the screen with his name and the stats. And when the ball was hit, it showed where the ball was going. It showed which fielder fielded it. It showed him advancing the bases. So you could look up, and there's the game right there. Even if you weren't really paying attention, you knew where you were in the game. I just thought that was fascinating. Just to look at it. It was very cool. Of course, with the payload, the data rate reduces slightly with the audio. But you can think of the extra data capacity as an SCA for AM, alternative revenue source. Haven't had that before. So, just consider that, if you had an FM that's been profitable, and maybe part of what, depending on the market, part of what possibly made it profitable was the fact that you could rent out that SCA. You'll be able to do that with your AM now. And that's basically the presentation. You've seen it all. We're going to open up the questions. I don't know if the Harris guys and the Ubiquity guys want to do anything. We do maintain an iBot page on the WR website, and we have been very forthcoming with what we've been doing. We stub our toe or skin our knee. We put it right there on the internet for everybody to see. We have nothing to hide. Whether it's good or bad, that's for everybody to decide. We happen to think it's a good thing. But if you want to write down this URL, it's www.wor710.com/engineering, that's with a capital E, /IBOC, which is all lowercase, /hdindex.htm. It'll take you to audio samples. It will take you to we've got facts about our installation, what we did to put it in. We've got pictures of the installation if you want to see what it looks like. If you didn't see it today, if you want some better pictures, you can send an email to Carrie and I. We'll be happy to talk to you about it. We'll answer your questions as honestly as we can. Like I said, we've really got nothing to hide and no reason to hide from anybody. We are a test station, and we're happy to help out. Now, before we close,
I think one of the questions that everybody asked me today was, what happened when you turned it on? And how many complaints did you get? We were, like Tom, we both went into this really with an open mind. We didn't know what was going to happen. The first day we turned it on, I got a call from a guy in Queens, Mr. Richards. So you're the chief engineer? Yes. Well, you're transmitting this horrible hiss. I said, well, what are you listening to us on? Well, I rebuild Atwater Kent radios. And my 1932 Atwater Kent radio is hissing. And I said to him, well, tell me about the radio. I said, well, put it in narrow and tune right in the middle, and the hiss went, oh, thank you very much. That is the only complaint from a listener we ever got. No other listeners called and complained. We had a woman on the air this morning, 10 minutes late, somebody might have heard it here in the crowd. She said, since you guys went digital, you sound so much better. And the fact of the matter is, there's not one HD radio out there except what we have, but because we've narrowed our bandwidth, we're a flamethrower. We're a talk station, we get away with the 5 kilohertz bandwidth, thank God. The analog signal is actually louder, and people have noticed it. What we weren't prepared for were the loonies that came out. And I don't know how, without getting too specific, there are some people out there that actually think AM stereo is making a comeback. Sequan AM stereo. And it's coming tomorrow. And there are thousands of radios out there. And you can still buy an exciter, and you should get it installed right away. I mean, these guys, not only did they
Hang on. Double up at the end. There's one for sale. Anybody interested? Okay, one for each channel, right? One for each channel? Two of them? Okay.
these guys thoroughly trashed us. I mean, you know, on these cockamamie message boards from hell, and all these radio professionals, WOR sounds like crap, and they're distorted, and we're also splattering hash from 670, all the way up to 740. I got a guy that lives halfway in Allentown, Pennsylvania, complaining he can't hear a station on the other end of Long Island, and the pattern's going the other way. But when we turn it off, it comes in perfect. It got serious. It got more serious than that. Not only were we trashed on these message boards and inundated with emails from these people as far south as Virginia and Florida and Australia. I had a guy from Australia tell me that I was interfering with something in Australia. I said, boy, Tommy, you really built that radio. You did a good job. We were not prepared for the abuse. I'm at the transmitter in the middle of the night, and I just got done changing the air filters. I had to count them on the air, and I was monkeying around with the wiring in the back, and I wanted to make it a little neater because I knew you were all coming. And I don't want to be too embarrassed. So I unplugged I plugged that because I better see if it worked. This is in the middle of the night. I put the carriers on. 2 seconds later, the phone rings. Now, our transmitter phone has been the same number for the last 30 years, and it's all over town. Turn that friggin' shit off! In the middle of the night, screaming obscenities at me on the phone. We don't need this abuse. Yeah, there it is, right there. You know, and then we found out that on these message boards, every time I would put the Continental transmitter on the air, or I would shut the iBot off for whatever reason, like we're doing a software upgrade or whatever, a half an hour later on the message board, WOR is currently transmitting an NRSC signal. Isn't it beautiful? There's no hash. You know, we weren't prepared for that. We went into this, we thought, oh, we're going to test this, we're going to have listener complaints that they can't hear it. Not one legitimate listener from WOR complained about the reduced bandwidth. If anything, they said we sound better. That's right. Go figure. But the abuse part of it, we were never prepared for that.
And quite frankly, most of these people have been contacting us, and they want to know where they can get their HD radio. I'm serious. These people are adamant. Why can't I buy one now? I know. I
had Glenn Walden from Ubiquity last week, came out, took a tour. He said, Kerry, he says, as an engineer, he says, how are we doing? What did we do wrong? I said, what you did wrong, you should have had the radios before you had the exciters. Yep. That's what I told him. And he says, well, what do you think is going to happen? What do you honestly think is going to happen? And I go, Glenn, I don't know. I said, the testing I've seen, and we tested it at night, the carriers are very robust. Tom got all the way to Allentown, and at night, it seems you need more digital carrier than during the day. The only concern as an engineer and concern for people that may live in the middle of Pennsylvania that listen to KDKA or WLW, and as far as I'm concerned, is critical hours. We may have to do something about that eventually to get nighttime service. They may have to lower the carriers a couple dB during critical hours, but at night it seems you need more power than you do during the day. So basically, as just a nuts and bolts engineer, and that's all I am, this thing really works, and it's very impressive. And most of the people that have seen it, they're startled. That's off the air? I had a guy today who says, that can't be off the air. Reached around back, here's the antenna. Now it's off the air, so it is impressive. And it is a test. We've kept that in mind. And all the criticism, we keep telling these people, we've invited them to come over, they never show their face. But the abuse was the part we weren't prepared for.
In regards to the testing and such, some people asked me today about the robustness of the signal. Going under bridges, not an issue. Going under Steins, not an issue. We went up Route 17. One of the final leg in our journeys every night was to go up Route 17 because I live up near Newburgh. Russ was staying with a relative who doesn't live that far from Newburgh, and we just went up Route 17 as our final leg. And up north of Paramus, our upper sideband starts disappearing. I was driving and I'm watching the day. I'm looking in the rearview mirror, and there's this. I said, Russ, where the hell's our upper sideband? I don't know. Yeah. However, we took it all the way to the New York, New Jersey line, and at that point you can't listen to the analog. It's so noisy. but we held the digital up to that point. We went down 40th Street, New York City. Our offices are on the corner of 40th and Broadway. I come down 40th every day. There are several locations on 40th Street where the signal gets noisy and you can't listen to it in analog. We pretty much held it solid digital, all the way to Lexington Avenue, where there are 4 rather large buildings that form a very large box. And on the spectrum analyzer, the entire AM band went bye-bye. So, how can you expect to hear it? We came through the intersection, came right back up, went into the Queens Midtown Tunnel. Of course, they have a leaky carrier system that limits you to about 4K, so it stripped the sidebands off. And Russ looked at the thing and he said, "Oh man, we lost the GPS signal. How are people checking this recording going to know where we are?" Welcome to the Queens Midtown Tunnel. Okay, well, we found that out. So we came out of the tunnel. If you're not from the New York area, when you go to the Queens Midtown Tunnel, the toll booth is on the Long Island side. We came out and we sat there, and of course it was shift change this night. God forbid you should be a customer at shift change. You do not exist. They will sit there, count the drawer, and get ready, and look at the watch, and then they will acknowledge your existence. We sat under the toll booth with noisy analog with a solid digital signal for about 5 minutes until they realized somebody was sitting there with this ghastly glow coming out of the van with all this equipment. And, nobody asked us one thing when we went through the tunnels. I mean, we could have bombed anything. No one said a word. We did have a little issue driving through on the first mile of the LIE in Queens. We're not quite sure what that was. We don't know if it was an overload from WQEW. We don't know if it was something with construction in the area. But after that, it was solid. The thing was solid. We had Joey Reynolds on the air with a acoustic guitar and a guy singing Christmas carols that one night. Honest to God, it was like he was in the van. It was pretty good.
And you were on the air too, Tom.
Yes, we got him on the cell phone. I actually got in a couple of great shots. It was wonderful. He asked me what it sounded like. I said, "It sounds like you're here in the van." I said, "With one minor exception." He said, "What's that?" I said, "You look better." And let's see, what was the other line that I used? He says, "Don't forget." He says, "The company Christmas party is coming up." He says, "Remember last year?" He's when I hung the mistletoe on Buckley's butt. And I said, "Yeah." I said, "I tell you, my lips are still brown. I'm still trying to clean them." And that put him away. They went to a commercial break. But it was fairly robust. It was fairly impressive. I didn't know what to expect driving around. It was pretty impressive with the coverage. And during the day, we had been running the IBOC carrier 6 dB under their normal level, which should take us to about the 2 millivolt line, which for WOR is right about Philadelphia, and we fall apart at the Philadelphia city limits. And it's solid all the way down the pike. And there are some serious power lines that go over that pike, and it doesn't drop out. So.
Where can I buy a radio?
Well, Ken, we're going to buy a radio.
Coming out this year.
Ken has it in his garage.
Tom, do you have the slides, the CD? Because I can show you what's coming out.
I sure do.
It's really, we have a response page on our public website. And every morning, Tom and I get up and check our emails, and there's always one or two, "Where can I get an HD radio?"
Well, HD TVs have been out for a while, and they have the opposite problem.
Right.
Yeah, but I can't convince my wife that I need a $7,000 television hanging on the wall.
You can't see it over the air anyway.
And quite frankly, with my DirecTV dish, I get 200 channels of Saturday Night Crap-A-Rama. So
But it's
I don't know what the right answer is.
their interest. There's a lot of public interest, and it's amazing.
What are the radios supposed to cost?
Russ?
By the way,
That's this gentleman who's driving. I'll give you a whole. I'll take you in a second.
All right, hang on a second. The other thing I'll say about the installation really was simple. It took me longer to run the 110 volts from our UPS on the rack over to the transmitter, and the Cat 2 Cat 5s, which you can see I just wire wrapped over. That took the better part of an hour. We were literally, if we had that ready, it would have taken us a half an hour to turn it on. It was amazing.
we've never seen a computer before. Please bear with us. There are ladies in the room. We don't wait for Microsoft. Microsoft waits for us.
I had a few top managers and they said, I can't justify it.
Jeff will address that as soon as he gets his presentation.
On the most of units being sold. Next year.
What we have done was those broadcasters who were signed up licensed, promised to make a equipment purchase and use their best commercial effort to get on the air by the end of the year 2002. We waived all of the primary audio licensing fees, the lifetime fees. We are in discussion now as to what type of incentive we're going to have for the next level of adopters. And right now it looks like we'll have an X percentage of the licensing fee for a Y number of broadcasters before the month of June. But we haven't decided what those numbers are. If there were no waivers of the licensing fees, a lifetime license fee would be 15 times your FCC assessment. That would be, again, that's a one-time lifetime fee that can be paid in full or in 10 annual payments. But again, we're still discussing how to, or what incentive we will have for the next level of broadcasters. But right now I can say it'll probably be for some X percentage of that fee for the first Y number of broadcasters of the next level to join the early adopters. Yeah.
What is lifetime?
Lifetime of the ownership of that station for that station.
So if I sell my station, that license that you guys have...
It's much like a driver's license. You can sell your car, but you cannot sell your driver's license. You still have to go back to the state to get your license. Now, obviously, if there's some relationship that we already have with the broadcaster, we already have the equipment. You can transfer your equipment to another owner if you let us know. So that again, but the new owner has to have a license to broadcast, and we will negotiate. We will speak with the new owners about how the former owner, the original owner of the license, achieved it, and then we'll be in discussions as to what licensing fee will be for the primary audio.
Just a couple slides here.
Okay, well, here's our station licensing map of the United States. You can see we have a pretty good geographic coverage in the United States. Now, the green states show all the states that have a licensed broadcaster in them. And as you can see, in Seattle, we have 6 stations licensed, San Francisco 9, LA 7, Dallas 3, Houston 1, Miami 16 licensed stations in Miami, Atlanta 6, Philadelphia 6, New York 6, Boston 9, Detroit 9, and Chicago 9, and Detroit 7 of the 12 of the 14 top markets that we have coverage in. And we have right now 130 stations licensed. And our hope is that along with the broadcast equipment manufacturer, that we would have a majority of those turned on this year. 46 groups, 6 of the top 10, 12 of the top 20. You can read pretty much what we have. 26 states. So we have a good coverage and a good diversity of formats. About 70-30 split between FM and AM stations. And again, we have all formats we have covered. People have volunteered with sound license from adult contemporary, rock, classic, urban. We even have educational channels, children's channels, Christian channels, religious channels, R&B and talk. So
we're not only geared to a certain format group or a certain a certain market group. It seems to be accepted in ranked markets, and even I think we have 4 or 5 unranked markets that have representation right now. So our goal is, again, that we would show what quality, what additional services you would provide to your listener, and be that closer to the community, and also add other revenue streams for the broadcaster. We have the first station. Now, there's some debate as to who is the first station. Let me rephrase that. There's some debate who the first station is, and we had a very long conversation as to how we're going to say this. KTKA was the first station to air. But in terms of digital broadcasting and the IBOC broadcasting, the reason why we say that WDMK is the first, because they were the first licensed station to acquire fully commercial operating equipment, not test equipment. So equipment that was fully commercial and purchased through manufacturers. Obviously, we had other people who were on the air testing and running and still testing and still in the broadcasting mode since turning on. But for whatever reasons and however we decided to define that, WDMK in Detroit was number 1. But as you can see, we also have WTMJ in Milwaukee, and we have a station in Birmingham, WTWZ. So again, we've crossed a lot of areas, we've crossed a lot of markets, we've crossed a lot of formats, and we can see that all the formats can see some benefit in the sound quality, and then all the station and station managers and ownership can see some benefit in the revenue increase because of increased number of listeners once receivers hit the streets, and also an increase in services that they'll provide. And again, of course, our own WOR is a leader in promoting HD radio. Now, our projections for the year 2003 is that we will have 300 stations, which will basically cover 65% of the population radio listeners in the United States. In 2004, 800 stations, which will cover 80% of the population. What are we saying? We only have 20% of the population in the Midwest. But what we're saying is that we feel that with the momentum that we've already found ourselves with, it will carry us through to 2004, and as the services that we provide will increase, and as the technology software is even enhanced, you will see again an increase in quality, increase in coverage, and which would mean an increase in listenership and an increase in services, which ultimately means an increase in revenue. We believe, and we're all in the radio business. Semiconductor manufacturers that we have, TI is playing a big role in this, and we have Philips and ST. There's a Gear and Motorola. So we do have semiconductor manufacturers coming on and backing and doing what they can, because they see a need and they see a reason to be in this business.
I can pick up on some of that. Moving on to some of the technical aspects, one of the early development receivers is shown on the left-hand side. Today, about 2/3 of that box is represented by that credit card-sized IDM module. It's called a IBOC development module. It is the backbone for all of the IBOC HD radio implementation in the first-generation receivers. Most of the development on that board came out of our WOR AM, New Jersey office, so it's technology born and bred in the Garden State. The status of the radio receiver manufacturers: Delphi, Kenwood, Visteon, Alpine, Harman Kardon, Hyundai Autonet, Sanyo, Mitsubishi, Rakuten, Jensen, and Fujitsu. Also, Yamaha has moved from the group that was just looking at the technology over to the license category and Those are the manufacturers who will be bringing the first generation receivers to market. Clarion and Pioneer, Chrysler, Blaupunk, and Panasonic are still looking at the technology, getting their game plan in order. And Sony is traditionally a company that waits until a product is relatively mature before they bring it to market. So this is...
They are testing with us right now.
They are testing, that's correct. So you have a pretty good indicator that everybody's on board who is a player in the game and are moving forward to the marketplace. This was our booth out at the CES show a couple of weeks ago, January 8th and 12th. Kenwood brought one of their show cars out with a fully decked out trunk lid rattling sound system. This was the road to radio success. The wall with the new digital HD radios, and a close-up look at the group Alpine with their prototype radio in the upper left. It's a trunk mount solution, much like a CD changer interface. Also, the Kenwood uses a trunk mount solution. Kenwood, by the way, won a award from Popular Mechanics for the editor's choice for best new technology, and we shared that award with them. Vistion, many of you listened to that radio today out at the show. It's based on a Beethoven radio. This was in a Lincoln Navigator in our booth. Jensen's prototype, and the Vistion nav radio, which is the radio on the right-hand side, right there. Also, JVC has a great radio that they have brought to our labs, and we've been testing with that. It's a single DIN radio. Many of the other radios you see were either double DIN or units that use a trunk mount package. Delphi, another OEM supplier like Vistion. Delphi provides radios to General Motors. And Sanyo, out with their prototype. The only one of the group who announced a specific target on receiver availability was Kenwood, who has announced second quarter of this year. So a couple months away, you'll be able to get that fancy Kenwood receiver. The head unit runs about $150, and the trunk mount box is around $350. So you'll have about $500 in a first generation radio. That technology cost is about $100 over conventional technologies today. You can pretty much expect to see that cost go in half each year as the technology moves forward, and certainly after we're into an ASIC chipset. Probably the most interesting and attention-getting at the show was the Vistion nav radio. This had a demonstration of what are known as on-demand interactive audio services. This is radio on demand from the aspect of news, traffic, and weather information, where it's streamed in the background, as a data channel on the system, and provides news, weather, or traffic on demand. So you're coming up, there's an accident, you can punch the traffic information and get the latest that's been cached in the radio. Additionally, this is a radio set that has personal radio service. Think about it as TiVo for radio. This allows you to time shift program and listen to it on your schedule. So there's a whole bunch of new technologies that are going to be coming along with IBOC as the package. The first portable HD radio was shown in the upper left, made by a company called Perstel. This is a little MP3 and HD radio receiver. It's about 3x5 and about 1.25 inches thick. Runs on a C64 platform. Can also serve as a hand warmer because it has pretty good consumption. But the radio apparently works pretty well. Harman Kardon and Kenwood will be introducing home receivers. Here's a line of their AV receivers that you see. And there is the award from Popular Mechanics for the Kenwood receiver as well. Let's see what we're talking about. Data capacities. We saw a bit of the AM data capacity today out at the site, being able to display song title, artist information, or post commercial content or call letters. On the FM system, you got a little bit of a larger data playing field. The hybrid mode is with carriers illuminated between 130 and 199 kilohertz. At that level, you have the ability to transmit 96 kilobit audio and be able to send song title, artist information like you saw today. If you are willing to scale that audio level back, say to 56 kilobits per second like satellite radio, you would be able to take about 48 kilobits per second of data capacity along with that. The extended hybrid mode, this is illuminating carriers down to about 100 kilohertz, so they're between 100 and 199. You're going to add a couple of dB signal to noise to your SCA region, bring your analog signal up by a dB or so. You now pick up an extra 51 kilobits of data capacity. This is a transitional mode, when you're moving away from your analog SCAs and bringing those services over to the data side of HD radio. After I've retired, some 10, 15, 20 years from now, when we can move to an all-digital world and the last analog listener has died off, we'll be able to remove the analog carrier and pick up an additional 150 kilobits of capacity. So there's certainly a pot of gold there at the end of the rainbow if we can get there. AM capacity, once again, we have two modes, all digital and hybrid mode. In the hybrid mode, you're limited to about 36 kilobits per second. In the all digital, you can have about 60 kilobits of capacity, but because you don't get full recovery of all the data, it ends up working out to be about 46 kilobits per second of throughput on the system. There's quite a bit of wireless business that's going to be out there. The estimates are that the total market will represent $63 billion, and they believe that iBox percentage of that will come in around $5.3 billion by 2010. So there is some financial justification for making this move, and we realize that for the early adopters of the technology, much as Tom and Kerry are finding out, the pioneers get a lot of arrows in the back, but there is also a benefit out here for the corporations that do back it. We're able to even show positive return for stations that adopt the digital technologies by bringing data services all the way down through markets 250. Obviously, the rate of return is going to be a little bit slower, but here in New York, you could probably wrap it up in about 3 months. Since we talked a bit about the AM, just like to go through the FM quick for you and just give you a brief overview, and then we'd be more than happy to take a bunch of questions from you. OFDM is really a system where we're taking an input data stream and going into a serial parallel converter, where we individually modulate up to 191 OFDM carriers in the case of the FM system. The waveform for FM in the basic hybrid mode has carriers between 129 and 199 kilohertz. In the extended hybrid mode, we add carriers all the way down, in addition, between 100 and 129. So the total span is from 100 to 199. For the old digital world, you take the analog away, you add an additional 150 kilobits of capacity into the secondary services. Secondary services are transmitted 10 dB below the digital. However, in the digital mode, we raise the digital carriers by 10 dB as well. Now on AM, we have the tertiary carriers, which are QPSK, complementary coded carriers. Complementary coding is an interesting method where the upper and lower, when combined through a linear filter, will cancel. And by doing such, you remove virtually all of the host compatibility issues. It does require that the filter on the receiver and the antenna system and transmission path be linear for that to work properly. Otherwise, you start increasing the chance for some host compatibility problems. Secondary carriers are 16 QAM. This is operating between the 5 and 10 kilohertz region, and between the 10 and 15, there's 64 QAM primary carriers. All digital mode, we go with a 64 cram block for the core and backup audio, and all of the enhancement shows up in the sidebands. And in the all digital, we pull back to a 20 kilohertz wide system. FM. FM, you're dealing with 10 partitions in each of the main primary sidebands and 4 in each of the extended partitions. I should say up to 4. It'll either be 1, 2, or 4, depending upon the mode of operation. The all-digital version adds, once again, 10 partitions in the main portion of the secondary and up to 4 in the extended, and 12 protected carriers that are the most protected information in the system. In each of the partition groups, we transmit reference subcarriers. These provide very critical information to the system on carrier state. So we're able to extract a lot of information and use this for guiding the adaptive equalization in the receiver. Basically, it's kind of just all the same thing with the partitions. Stereo considerations, particularly on the AM. Avoid audio bit reduction. Bottom line is that at 36 kilobits per second, you're removing about 99% of your audio content. There's not a lot of margin to do anything else. On the FM, compression ratios up to about 8 to 1 appear to be relatively transparent. The problem with transcoding is that you smear and spread the psychoacoustic model, and you end up with just very poor definition in the audio. The actual pack format takes an adaptive signal filter bank, compares that with perceptual model, then fits the model to the filter bank, and then is fully quantized and goes through the noiseless coding process into a bit formatter. The actual pack bit stream contains sync pattern, control information, header information, coding modes, and then the actual left and right data, and then your ancillary data. This is where your song title, artist information is transmitted. We talked a little bit about the rate conversion and lock. The systems all except 4418 ES3. They actually do word clock generation on a board in the exciter. That is handed off to the rate converter in the transmitter, the exciter. The way this actually looks is the block. We have a GPS receiver that provides a 1 pulse per second signal to the word clock reference board. And that hands off the word clock to the rate converter, where we have 2 locked AES streams coming out. One goes to the IBOC audio processing path. The other one goes through a digital delay line on the analog path through the exciter, where it then meets up with the analog audio processor and into the in this case an FM exciter. Delay time through the system. I would say maximum delay that I know of, depending upon the modes, is about 9.5 seconds.
Or 8.5.
It is mode dependent. The system has 4.5 seconds of diversity delay. That's intentional delay. The reason your timing was perfect. The reason there is delay in the system. Digital STLs were already introducing 120 nanoseconds to about 14 milliseconds of delay. The new generation's digital audio processors were offering about 4 to 20 milliseconds of delay. In the case of the 8400, it gets pretty ugly. We're looking at easily being over the 20 millisecond range at this point. The threshold of fusion, Haas threshold, is at 20 milliseconds. This is where you start hearing percussive echoes because it's conducted through the bone structure to the ear, and it arrives out of sync with the audio coming in through the headset. So you start hearing echoes coming back. Well, here we are with IBOC. HD radio, DSP presently is about 2 seconds. Where it says 4.5 seconds there, it actually should read about 7.5 seconds. But you have a total delay in the system up to about 9.5 seconds. Once you were beyond 20 milliseconds, it really didn't matter, except for those who want to listen to the game at the stadium. Basically, STLs, today's generation, you're going to need to somehow bring AES audio to the site, either through an analog to digital converter. As Tom mentioned, that's probably the simplest way for many of you who are running analog STLs. If you're running a composite link, if you're an FM, you can get away with using something like a DSP 6000. And Tom even feels that it might be acceptable even on the AM. Certainly, linear is better if you can afford to do that. Basically, if you're going to transmit 20 kilohertz audio for FM, you're going to be using up almost a full T1 to transmit it linearly. That's 1.48 megabits per second. Data capacities of the system could go as high as 91 kilobits per second. In the future, we're probably going to end up having the flexibility to bring the codec back to the studio and therefore reduce the burden on the STL systems. But that's going to be second and third generation systems. AM STL needs certainly a little more relaxed. 1024 will give you 15K linear. This might be a good dumping ground for a lot of the FM STL systems as you upgrade. And so within your chains, you may want to look at how you appropriate hardware. Just a quick view of the methods of implementation for FM. Low-level combining. This is essentially combining at exciter-level signals through linearized common amplification. High-level, this is the brute force method. This is where we're taking a lower-powered digital transmitter, combining it through a 10 dB injector combiner along with the analog signal. Our waste product in this example here is about 2 kilowatts of heat. We've got here a case of a 10 kilowatt antenna input power. Takes 11.1 going into that ejector combiner, so you're going to lose about 90% of your analog power, 10% of your analog power and 90% of your digital power through this. It's a great way on a night like this to keep warm, but you might want to look at the impact potentially on your site. Separate antennas. This is emerging technology. There's a lot of hope because it's the lowest cost implementation. Obviously, you can see here you're running 100 watts up the pipe for the digital side. That gives you the same effective coverage as 10 kilowatts. What a savings. The problem being that by having two separate points of origin on the signal, you can create potential host compatibility problems. I'll show you a slide here in a second relative to that. The actual hybrid injector used for the high-level combining takes the analog signal and combines it with the digital signal. Digital signal combines with the, this is an XP, is it? No. All right, well, the animation's not going to work quite right. But bottom line is you're mixing the two signals and you end up with waste product, that being heat, 10% of your analog, 90% of your digital. Just some numbers to assign to that. WETA down in Washington, D.C., one of our test facilities, 25 kilowatt TPO, requires 27.5 kilowatts of analog power in to the injector and 2.5 kilowatts of digital power in. So you're going to need 10% analog transmitter headroom to work with that injector combiner. You're going to need a HD-ready exciter. You'll need a separate linearized HD radio transmitter, the injector combiner, desirably separate audio processing for the two paths, remote control capability for the additional transmitter. And if you're going to look at high level, you really better evaluate your cooling and power loads for the room. Obviously, it's also a site space intensive system. The first generation systems are computer-based, so I highly recommend UPSs as well, but UPSs also come with their maintenance headache as well. Pre-delay monitoring capability. Generally speaking, it's a great dumping ground for your old audio processing. Put it in the air chain, let the jocks be happy with their voice, and be done with it. Run off program feed. They'll never know the difference. Low level is pretty much the same thing. Here we're just using one common amplifier. I want to move on to the discussion on the dual antennas, just because for some of you it may be an issue. We conducted some testing. Mike Ferriol was here. Mike gave us a lot of help up at WDHA in some dual antenna testing. Here we took a run and compared the host analog signal to the digital and how they tracked. Basically did pretty well through the whole path. It was real encouraging. Out in Seattle, we also had similar results at KBKS, and that was a tremendous success as well, where we split the master antenna into the upper and lower, used the upper for analog and the lower for digital. Granted, it was at half the effective radiated power because we dropped the gain of both antennas, but coverage in downtown Seattle was without a hole, so it was really pretty decent. The issue with separate antennas is that the multipath fade point, the differential, if it exceeds 1 foot, it starts becoming statistically significant in the host compatibility. Here we took 3 scenarios. The lower dotted line would represent a Class A facility with center irradiation at 328 with an iBox signal at 288 feet. The other 2 scenarios, the red line would represent a Class B facility at 500 feet with digital at 460 and a Class C at 1,000 feet with digital at 960. And as you look at the charts here, when you start getting beyond that 1 foot point, that's that first blue line you see there, for the Class A facility, that would be at about 1.2 miles into the tower. For the Class B facility, it would be around 3.75 miles. And for the Class C, it could be as far as 7.5 miles out. So what we're talking about is increasing the probability of host interference. Ideally, you would like to be able to maintain up to 20 dB of differential between the analog and digital signals. So the digital is shown in blue, the analog in red. Obviously, if the multipath fade points aren't aligned, you change that ratio. So over that area is where you start realizing some increased probability for host interference. ERI and Shively have been very active proponents of dual antenna technologies. Here you see some early development work from ERI showing that with separations of as little as 20 feet, they're able to offer about 40 to 42 dB of isolation between the bays. We used an existing master antenna multi-station combiner and fed into the alternate input port, isolating with a circulator, and then connected transmission line to the point at which normally the station load would be attached, and used that as the feed to the lower antenna base. So here we utilized almost all of the existing hardware to combine the signal, and it worked out very well. This is known as the Freinwald method of combining, named after Clay Freinwald, who came up with the concept out in Seattle. That's the actual hardware and how it was all hooked together at the site. Circulators are kind of interesting devices. There's basically 2 varieties, the distributed constant and the lump constant. They offer isolation between port 1 and port 2. You have low loss going from port 1 to port 2, and it didn't animate right, but high loss from port 2 to point 1. A circulator is the same as an isolator, except in an isolator you don't terminate port 3 with a load. Here you have the construction of the circulator. You basically have a Y junction at the center that goes out to the terminals. On either side of that are ferrite garnet discs. Then they have a ground plane and then an upper and lower magnet. These were some of the test loops in Seattle that we ran. This was with half power all the way out of the Cougar Mountain site. The issue of host compatibility on a well-designed receiver isn't a problem. Even under normal conditions, you have quite a dynamic range that occurs between the analog and digital signals. In many cases during multipath fades, we've even seen the conditions go negative where the analog is below the digital carrier levels, and still on a well-designed front end we don't have any host compatibility issues. But on poorly designed older generation receivers, you could get into a host compatibility problem. Our recommendations basically are that these dual antenna systems should be confined to similar mounting methods on a tower. If you're on a uniform face, it ought to be in the same orientation, same relationship to the crossbars. If it's on a pole mount, they ought to be on the same azimuth and of the same design. But basically, you want to maintain that ratio of 20 dB wherever possible. Those of you who have notch filters, you might have something to deal with. There's a little bit of attenuation to the sidebands and a whole lot of possibility in the group delay area. So some group delay correction, many of the manufacturers are looking at ways to dynamically correct for some of the group delay, and we may have some solutions that are a little less brute force than are in the field today. General bandpass for a 4 or 6 pole elliptical is pretty good. generally doesn't pose any problems as far as transmission of the sidebands. Group delay, once again, can be ugly, particularly on some sharp skirts. But there are group delay corrections that can be implemented as well, but they are large. That's pretty much it as far as what I have, and I'd just like to thank Tom and Kerry for not only putting the whole thing together, but stepping out there when there's so many aerials coming at them, and you guys deserve a hand.
Anybody have some questions we'll take them? I just have one request, Mark. I wish you change the tubes in your at WOR AM radio immediately. So does anybody have any questions?
One question about the receive portion. I did some of the experimenting with NBC and the COFDM APSB thing. Has anyone done any testing on the receivers as far as mobile? As say in a car going 20 as opposed to 100 miles an hour, which is what everyone drives, you're going to get data loss. Can anyone measure that?
You're basically talking about Doppler shift. We had a guy named Keith. Keith used to do a lot of testing, probably close to 100 miles an hour. Virtually all of our test data has been taken in mobile environments with the test van and has been typically done at highway speeds. I would say probably some of it at speeds in excess of the posted speed limits in some cases. But we haven't seen any problem with the FM or RPM system or AM.
Any other questions?
Another question.
Yes.
How did Ubiquity solve the problem when you have two stations, 20 kilohertz spacing, where the IBOC lower sideband from one station and the IBOC upper sideband from the other are overlapping each other? Do they, almost like on, I guess, FM heterodyne or AM heterodyne, or does the receiver distinguish between the two different stations? I can use two frequencies as an example.
Oh, it's a sensitive spot.
No, not at all.
Well, as you're probably aware with the AM system, the performance of the system is very much receiver dependent, and most of the receivers that are out there now, especially the automotive receivers, have a roll-off at 3 kilohertz or less.
I'm not talking about analog. I'm talking about will the IBOC receiver be able to determine the difference between the two?
Oh, you're talking about two IBOC stations.
Two IBOC stations, correct.
It depends upon which mode you're running in. If the mode you're running in requires that both sidebands be recovered, the receiver will make one of two decisions. If both sidebands need to be recovered, it's going to collapse back to the mono analog signal on the receiver. In the case of the core and enhanced mode, where you can lose a sideband and just basically run with one set, then you can recover the signal. The robustness of that signal, however, will be limited because you're only recovering one.
Yeah, so I don't have enable error protection, but the system won't be as robust.
Well, and the other thing too is that when we initially went into this, we had considered running WOR at 7.5 kilohertz mode, which would be you have to recover both sidebands to hear the digital signal. When we realized that we had no wideband AM radios, I have 9 radios. I even have the latest Henry Kloss table radio, and I thought for sure I'd hear the sidebands. None of these radios are the lowest wave radio. It rolls off at 4 kilohertz.
I'm not
I don't understand that. The point I'm trying to make to you is that if we get the bullet at WOR, we're running it in a full blast 5 kilohertz mode. So you don't. The reason Tom and when we take the truck out, we got very good results is because you don't need both sidebands to recover you don't need both digital sidebands to recover the signal.
even if the station is broadcasting in stereo on the digital, You don't need both sidebands to hear the full digital stereo?
It depends on whether you're running unequal protection or core enhanced, right? But yes, essentially all of the stereo information is contained in either the upper or lower.
But the stereo left and right are not in one or the other, they're in both.
The question that I have is about the software upgrades. You're on version 2, you're about to do a version 3. What have you done on the receiver side to anticipate upgrades to the transmission side?
Okay, on the receiver side, basically you're dealing with a fixed implementation. End of February is, I think, when the TI chip kind of goes to press. When that's set, the receiver won't change. All of the implementations, there are roughly 5 knobs in the algorithm, can be changed and dialed and modeled. With that can be changed on the transmission side forever.